And I'm going to use this scenario, like the data set that I show you. We have semiconductor lots, and this lot will go into a tool, having a 3 different chamber for this one tool. And then for these parameters that it's going to use, right, for the deposition process will be different chamber, different current with time, temperature, and flow rates. And then of course we will send for roughness and thickness measurement. At the end, you will send down for this U, this probing to get the final U number. Okay, so this is the data set that I just used, I show you just now. And let me go through again. You will see that I have U, I have this measurement after the deposition process, final probe U. This label is to do with the U, right? You can see OS is kind of low U. However, in green, under control, which is more than 90. Let me see if there's any condition. We don't have. Likely to be 92 or 93. Right? This coloring is actually based on these are if-else condition. And then we have these different factors, eight of them under here. I'm actually grouping them up, 8 of them. And we have validation, this column. I will make use of, maybe this one will be the one that being used by in the native predictive modeling, right? We have this validation column. This is another way, is another option for you to do a validation column. So this one is actually built by the validation column. And the other model, I will show you all the other models, right? We have this maximum likelihood generalized regression. We have also elastic net generalized regression. We have neural net boosted. We have bootstrap forest. We have boosted tree. So I can take a look using Jump Pro. I can take a look on all of them, right? The performance. So this is a training performance. This is a validation performance. I can put them up and line them up side by side so that I can know. Seems like my elastic net, right, is the one, is the best one. It's quite comparable with the maximum likelihood. Okay, so this is my current performance, and I can then now try to use this add-in to fit some deeper neural or larger neural, right? I can go there and showcase to you. Because I already have this K4, I'm not going to build it again. It's there. I can use of this torch deep learning. So I'm going to predict Y response U. I can put all my X factors, and it's either I use this tree or I can make use of this. I'm going to show you, I'm going to use this tree first as the best practices, but the model that I am having now, right, the one to compare with is actually using this one. So later I'm going to also fit cross-validate with the one that's similar to what I'm going to compare with. So if I click validation here, right, I go to the next page. This is a user UI for the torch deep learning. So here it will state that you are trying to target you to see the response. Total, we have 8 predictors and 13 features. So this 13 feature is mainly coming from, if we have categorical data, which is 2 ID and chamber ID, right? Each of them having 3 class and 4 class. So this one will make up into 7 features, and 7 plus the remaining 6, I have 13. So this is how it come up with 13 features. Right. At the back, you can take it as a one-hot encoding. You just change this one to a one-hot encoding. I'll show you how it works. Under column, I can use the utility make indicator columns. Click OK. So you see CVD1, 10, CVD2, 10, and CVD3. So this is actually a binary, right? But I'm going to use this one. At the back actually is using this one to train the model, right? And chamber is the same. If I have A, 10 for A, all of them are 1 and B. So this is what we call one-hot encoding. So if I look at that, I'm literally using this, which is 13, right? Features. So now you see why this is 13 and why this is 8. Okay, just like at the back, this is how it works. Let me just delete this one. Okay, so Let's just quickly fit one, right? I'm going to use the standard, this setting, go for one time. I hope that, because my Zoom is also using some RAM, some memory, and I hope they will not be too long. Let's see how it works for first time. At the same time, I'm reading this. Oh, this here. I can show it to you. So you can see that it's running second fold, third fold, B, and epoch is the one that I'm setting up here. So you can see this window showing this progress. It won't be too long because it's still a tabular data, right? It's not image data and text data. So it will be quite fast. Over here, you can see now I have validation R square of 59, not very good. But if you want to use of this training history, of course, you want to look at the loss, right? It still seems like decreasing. Right? I can further train for a longer epoch so that more cycle will be run through and then the model will train with even better results. So I might just quickly maybe jump to 80 and let it run again. You can see over here the validation accuracy also start to get higher. Over here, I only can get 59 average. In average, then this one will be higher and higher after some time. So epoch is 80. It's actually cycling cross few fold. Over here, you will see I have 3 fold, right? And each fold I have 5 different parts or split set. So at the back, jump is actually running 15 times, right? Because it's trying to cycle through all this. So it's 15 times, 3 times 5, 15 times. And this batch, you'll see is jumping like 128 every single time, right? It's increased by 128 this batch size every single time. I'm going to show you where you can set that up later on after this is completed. Just a while, let me see if we have any question. Yeah, I see someone mentioned Jump Pro 18 will be released. Oh, it's released yesterday, 19th of March, not in April. Okay. The link for this add-in, yeah, we can send that afterwards. Right. So it's done. Now I'm hitting 87. Okay. Let's see what we have for previous model. 88 and 87, right? So you can see that you can also hit that kind of performances. But this is actually a relatively small data set. Normally, you will not need to really use deep learning to do that. I just want to show you how it works in this interface, and you can get equally good results. Sometimes for smaller table, you might overkill it using deep learning, right? So you still might want to come back to the statistical modeling, advanced statistical modeling, and some of the shallow neural networks, things like that. Right? So you can get the same performance. And then if you go down, you will see that, as usual, if you are into this PyTorch, this deep learning, you have a train and validation, right? So this one, it seems like is already pair 2 over here. Okay, so you can't get any longer, even I increase this one to higher. Of course, you can try, but I'm not going to show that now. I think I try 160 is about the same. So I don't want to waste more time. So you can make use of this one to see if there's any overfitting. Of course, they ask some about 0.3, right? So this is the training and this is the validation. You have about 0.03 or 3% of overfitting. Then you can make use of the one option. When you open this up, you'll see that we have plenty of options for you. You no longer need to code. This is one of the painful areas if you are using Python or PyTorch, because you need to really go in and try to type it correctly for each of the from each of the lines, right? So this one with the user interface, you can just key in. If this one, right, layer size, I'm only having 1 layers now, and the 16 neuron. If you want to make it 3 layers, you can type it this way. Every single space is actually to do with another layers. 16 first layer, second layer 8, and the last one will be 4 neuron. And of course, the one that coming out is actually the one neurons that to calculate this R square. And this is the best size I'm telling you. Just now you see when I training, right? It actually keeps increased by 128, 256, and 400 something. This actually the every single batch that is loading in. Using this 1,300 data is actually loading in every single time, 128. This one will be, if you have not much of memory, try to reduce this because this one will be loaded into your memory or RAM. So this might explode your RAM if you have very limited memory or RAM. Okay, if you want to load it, you can just set it to 64. But this one will actually affect the performances if this data set is huge. And I'm not going to go through all of it because time is not really allow me to go so